Hi, I'm Mark Walker, and my group works on engineering high-throughput biosynthesis of natural product like cyclic peptides. We focus on a type of natural product called ribosomally synthesized and post-translationally modified peptides, which are initially made from a genetically encoded precursor peptide. And then there are enzymes that extensively post-translationally modify that peptide. Now, because these precursor peptides are genetically encoded, and because the enzymes that install that post-translational modification have been seen to have a level of substrate tolerance, these pathways are ideal systems for making very large libraries of natural product-like compounds, which can be screened for new and useful biological activities. During my postdoc work, I've developed a platform to display one type of RIP, or the lanthopeptides, on the surface of yeast cells, and used a variety of techniques to show that we were in fact displaying these modified peptides on the surface of the cell. I then created a library of these precursor peptides and screened them for new biological activity, namely the ability to bind to the alpha V beta 3 integrin. And we identified a number of lanthopeptides that were able to bind with low nanomolar affinities. And so what my group is working on now is trying to expand this yeast surface display platform to other classes of RIPs. So uh, less is known about the substrate tolerance of the enzymes that install the post-translational modifications on these other classes of RIPs. So we're developing a new assay to look at the substrate tolerance in a high throughput manner. And to do this, we're taking advantage of the fact that when these RIPs are macrocyclized, they're generally protected from proteolysis. And so our idea is that if a yeast cell is coated in unmodified precursor peptide that the enzyme can't act on, it'll be susceptible to proteolysis, and that proteolysis will release an epitope tag. But if it is modified, if it is cyclized, the enzyme will have been able to act on it, and it will be protected from proteolysis. And so we're beginning to work on this assay, and we see that when we don't co-express the post-translational modification enzyme, so all of the peptide on the cell surface should be linear, we do see a large loss of the epitope tag from those cells. But when we co-express the enzyme, we still see a population of cells that are retaining that epitope tag, suggesting that with optimization, we will be able to use this assay to broadly and quickly measure the substrate specificity of these enzymes. So thank you for your time, and please feel free to take a closer look at this if you would like. Bye.